In this tutorial, what we're going to do is look at designing the PCB to go with the digital die that we've put together previously. So we've programmed it and we've seen it work, so we know it's going to be okay. So we can make a PCB up. One of the things that I thought about as I finished the last tutorial, and this is something I've seen with people who've made these before, is what happens when you hit a situation like this. Let's say that we've got your circuit we've put together, and we're quite sort of young and inexperienced with electronics, and we decide that what we want to do is just, by accident, to touch the negative end of the battery onto the positive sort of input into our circuit, and the positive end of the battery onto the 0 volts end of our circuit. Okay, let's just go project simulation, make sure explosions are turned on, just to give you a clue as to what comes next. Let's see how that affects our circuit if we built it, soldered it together, made a case, built everything, programmed it, pushed it in, and then someone comes along and does this. Let's see what happens. Boom. So basically it blows up the entire circuit because we're sending too much voltage in here. The regulator isn't really sure what it is it should do with the negative end of the battery and so on. So we could do with actually providing a bit of protection to our circuit to stop Wallies from destroying it. And the way we do that is we add a component called a diode, which is just here. And I'm going to click, I'm going to pop that in and spin that around this way. What a diode does is it only allows current to flow through it in one direction. Okay, you'll see here there's an arrow that's pointing sort of effectively up. That's the direction that current's allowed to flow in. So I'm going to connect that up like that, connect down here, and connect down here like so. If I run my circuit, it runs exactly the same way it always did, no change. But what the big difference is now though is this. If I come in here and I connect the negative end of the battery to there, and the positive end of the battery down there, and I run my circuit now, nothing happens. Okay, although interestingly, my LEDs come on. Not sure what that's all about. Don't think that would actually happen in real life. Okay, double interesting actually. Okay, that shouldn't happen because I've got the negative connected up there. Okay, but in reality, take it from me, nothing would happen. It would be absolutely fine. Okay, so that's what we're going to do. We're going to insert a diode into our circuit when we design it. How bizarre. Right, so onward, let's design the circuit. To do that we click on here, which is the PCB layout option, and we click on next, and we then click on the option that says rat's nest. We could try, I mean, you're probably tempted to do this, so let's just explore that very quickly. We could make a single-sided PCB automatically, and click on next, and convert, and we could watch Circuit Wizard design the circuit for us. There it goes, popping all the parts in place, looking good. Do. Here you go, the bits. There comes the funky bit where it designs where all the tracks are going to go. And what happens now is this, okay? We end up with a PCB, which is, and I'm just going to try and measure this by clicking once on the circuit itself and just hovering my mouse just here. So I've got something that's 3 inches by 3 inches in size. I'm just going to change my measurements to millimeters, and I'm going to go project options, unit measurements, millimeters. There it is, good. A bit like that. Let's try that again. So it is 76 by 76 millimeters in size. So basically 8 centimeters by 8 centimeters is the overall size of the finished board. Okay, you've got loads of wasted space just here. On top of that, we've had to use some wire links, so we have to run loops of wire over the top of the board to make that work. Okay, loads of wasted space, no labels, and it still doesn't have all the connections put together to actually complete the circuit. So these green lines here, it means that the circuit at the moment isn't actually finished and doesn't work. So that's the computer's attempt at automatically designing the circuit. We're going to do it as manually because you'll get a better result. We're going to use this option that says rat's nest. We're going to go into customize. We're going to start by making our board as huge as we possibly can. It comes up 10 by 10 centimeters. We're actually going to make it even bigger, and then we'll shrink it as we go along. In the options list that you've got just here, these things are all fine. We can leave those as they are and go next. And when it comes to our component pads, we're going to use standard sized pads just because it's convenient to work with. And make sure that there's not a tick in automatically place components. And click on next and convert. So I've now got a nice blank big piece of PCB. Here it is. I'm going to make it even bigger so all my components sit onto it. And what I'm going to do is basically put my components one at a time and assemble it exactly how I want it to go. What I'm going to start with, what am I going to start with? I'm going to start actually with this. I'm going to actually put a pad, just a circle, in the top left corner of my board around about sort of here. The reason I'm doing that is once I've finished and I've made my PCB and I've made my housing, I'll need to be able to bolt the PCB to the housing for the die. And the way I'll do that is by having these little sort of blue circles in all the corners, you know, kind of a lot like this. Okay, and I'll basically just drill holes through those. It's just so I know that I need to leave. Oops, I keep that one. Know that I need to leave some space, you know, to include that once I've finished everything. So that's going to go up there. What I'm going to do next is I reckon I'm going to do my power first. So I'm actually going to build this circuit from the left-hand side over to the right, and so I'm going to start with power, and I'm going to put my power over on the left-hand side, I don't know, around about sort of here-ish, really. Okay, so I'm putting it on the edge, and there'll be just wires, you know, running off here, going to my battery. Okay, what's next in the circuit? Let's take a look. Next thing's the diode now. Okay, diode. So I'm going to take my diode and make sure I don't lift my PCB up. Just pop that up there. After the diode comes my voltage regulator. Okay, and after that I'll probably do the Genie chip, and I'll sort of put everything in packed around the Genie chip. So let's just pull those few components up just so they're ready to go. So there's a voltage regulator, and there's the Genie chip. And I'm actually going to zoom in on this section now so I can really focus on it quite tightly. Okay, let's think about this a bit then. So power goes just here. I'm going to use the unpopulated view as well, which is this one here, just so I can see where the actual pads are on my component. And if you look as well, you'll see you've got these nice faint green lines here, which indicate where the computer is telling you that things connect up. So the positive end of the battery connects to the positive end of the diode, the anode, as we call it in the trade. My anode actually, to me, looks kind of to be upside down. You know, I've got to sort of go up here and then down there at the bottom and back up again. I'm actually going to spin this around using this rotate tool just here. I'm just going to click on that twice. And I'm going to pop that in. I'm going to try and stick my diode on the left-hand side, kind of like that actually. Okay, I'm going to stick that there. I'm going to stick my power sort of alongside it a bit like that. What I'm then able to do is to draw a track that's going to connect these two things together. So I can click on the track tool, click on the first part, and click on the second part like this, look, and that track's drawn in place. I'm actually going to make my track a bit thinner. It's quite thick at the moment. I'm going to double click on the track tool, and it says how thick would you like your tracks to be. I'm going to make my tracks about, I don't know, just over half a millimetre, 0.6 millimetres thick, I think. Okay, and I'm going to delete this track that I just drew a second ago. Let's just do some deleting. Track tool on, and draw a track from here to here. That doesn't look a lot different, does it? That's because it's not. 0.6. Okay. No, there we go, that is thinner. If I zoom right in, you can actually see that now. That is a thinner piece of track, that's fine. Okay, so I've got my nice thin track that's put in there. I'm actually going to right click on my green line and go delete, because that one's done. Okay, so I don't need to work on that anymore. What else I thought might be quite nice is with the power, because the power gets connected and disconnected all the time, it's quite easy to break the power lead off. So what I'm also going to do, actually I'm just going to delete this again. I've changed my mind a lot. Okay, sorry about that, it's just PCB design. What I'm also going to do is I'm actually going to put another pad, this thing here, I'm actually going to stick this in the middle. And what I'm going to do when I actually make the board is I'm just going to drill a hole straight through that. And when I assemble this, I'm going to push the wires, imagine my mouse is the wires for a second, I'm going to push the wires through that battery hole, and I'm going to bring them down through here and then solder them. It just means if anyone gets hold of it and yanks it, it won't break. Okay, so I'm just going to leave that there. We call that strain relief. Really, really good thing to do. So we draw that track back on. I can't draw a track through here anymore because it's got a hole there now, but I can sort of come out a little bit to the side, round a little bit, and I can tuck back in there again like so. That's quite neatly done. Okay, so I've got that. What shall I do next? I suppose I can do my voltage regulator next. Now, a voltage regulator is the next component, so it wants to be fairly close to my diode. Just deleting some labels as I go along. My little pet peeves is these labels. Yeah, okay, the voltage regulator. The voltage regulator's got an input, as we know. It's got 0 volts or reference voltage, ground, and it's got its output. The input needs to connect to this end of the diode. Now, I suppose I could sort of slap that up here. That could work pretty good for me. But I know that also I'm going to need a lot of connections to the negative end of the battery, to this 0 volts part. So to help me to get that, I'm actually going to take this component and I'm going to rotate it around 180 degrees, like so. Okay, so that's done there like that, and it just means these two pads are close together. So I can now get my track tool and I can sort of drop down and slot that in there like this. Okay. One of the things you'll notice is that's where my diode's going to sit. That's where my 7 out of 5 is going to sit, my switch, and so on. And I'm careful to make sure that this component and this component aren't overlapping. If I placed components like I've done just here, I'd have a problem because the Genie chip and the voltage regulator can't sit in the same space. So I've got to make sure they're physically separate from one another. Okay, so I've got some power. What else do I need? This voltage regulator needs a connection to 0 volts, the negative end of the battery. Delete that one. So let's give it that real quick. And again, you always try and use the smallest amount of space that you can. So I'm going to pop out here, come down to about here, slip through here diagonally, come down here like this, and then sort of take that into the middle of that pad like so. Okay, you see that? So my green isn't touching this green here. The tracks aren't touching other tracks where they shouldn't be, so that's a good sign. Okay, so I'm doing that, about right. I can right there click and delete that line now because that one's done. Okay, what next? Genie chip. Genie chip needs 5 volts to power it. You can see this line just here, so I could place that about there. There's also actually another consideration that needs to be taken into account as well. So I jiggle while I'm talking. Another consideration that needs to be taken into account, which is I need to actually have a thing called a download socket. Which you don't actually look at in the circuit diagram, but you need to have. You need to make sure that you can connect this to the computer, and the download socket is how we do that. Now, when you design a PCB, the computer automatically gives you a download socket, which is this thing just here. It also gives you a couple of resistors as well that we didn't put in our original design. I've got a 100k one here and a 22k one just here. Let's just quickly look at the help files for Circuit Wizard, and that'll tell us how to connect these up. So I'm going to go Help, and Circuit Wizard Help. Down at the bottom, it's all about programming Genie controllers, and specifically the Genie C08 is just here. And at the bottom, it shows me a little circuit diagram look, and it says here's the most basic configuration. And you'll see that it says we need pin number 1 to have some power. Well, we knew that because we already put that in. Pin number 8 needs to go to negative end of the battery. We've got that already as well. That's good. But then the bit that we didn't sort of see before is where it says here that we've got a socket part called PR, that's short for programming input, and that needs to go through a 22k resistor into pin 2, and it also needs to go through a 100k resistor down to ground, down to 0 volts like this. We also need to have a connection to 0 volts, we can do that hopefully, and a connection to a thing called the status input, which we connect straight up to pin 7 just with a straight through wire. So let's add those in now. Before we forget, because you don't know, add those in at the end, they're quite fiddly things. So I've just held down the shift key while I clicked on each one of those just so I can pick them up one at a time, and I'm bringing that download socket up to the top. So what I'm thinking I'm going to try and do, because this download socket's like a headphone jack that you get on headphones on the MP3 players and things, it needs really to be on the outside edge of my PCB in order for it to actually be able to be connected to. So I'm going to stick it I'm going to try and stick it up here in this top corner basically. Let's try and do that and see how we get on. I'm going to stick it about here. And let's look at which pin's which. This pin here, that's ground. Oh, that's quite handy because we got 0 volts sort of reference just here. Look, so we can go straight into there. So that'll kind of work. So I'll sort of come out, down, and tuck you into there. So that's that one done. Maybe slide that a bit of diagonal, looking good. What's the next one? The next one, we'll do the fiddly one with all the resistors next. That's this one here. I think that's programming input. So we said that the programming input goes through a 22k resistor and then into pin number 2. The way I think I'm going to do that is I'm going to take this resistor, delete that label, so take that resistor, I'm going to rotate it 90 degrees, I'm going to pop it straight underneath the download socket like this. And I can then connect a track from programming input to the resistor, and then from the resistor, slide you along a bit, I think, you about there, yeah, I think about there, and then have the other end going into pin number 2. Now, when I do this, I'm actually going to try and be a bit clever here. Rather than use this space, because I think I might need this a bit later, one of the things I know I've got to do, for example, is I've got to get some power from here into sort of pin 1. That's going to go in there, hasn't it? Yeah, what I'm going to do, I think, is I'm actually going to cut down, because all of a sudden I can't get to pin number 2. I'm actually going to cut down through the middle of the Genie chip. Okay, so let's do that. So I'm coming from here, add a little bit, down a bit, and then into pin number 2 like that. Okay, it's quite a handy thing to be able to do. I've then got my 100k resistor. I'm going to rotate that 90 degrees as well. And stick you underneath there, a bit like that. Okay, so that's looking alright as well. Now the 100k one, if I remember correctly, it goes through the programming input and then down to 0 volts. And 0 volts happens to be up here, so that's quite handy. So let's draw that one up. So connect you to here, and I connect you without touching this one, and bring it out just a little bit. Up and a sort of diagonal like that. That looks alright. Should I go straight in there? No, it's a bit close to that. Go there, connect it in there like that. 0 volts, lovely. So that one's connected up as well. Then the last one I've got is this thing here, this status input. And for the status input, I'm going to come down a little tiny bit, out a little tiny bit, down a little bit, and connect that up there like that to pin number 7 to this pin just here. Looking good. Okay, that's my download socket done. I've got a lot of this green spaghetti starting to creep in, so let's actually have a quick de-spaghettify while I'm here. When you try and click on those green wires, by the way, you just right click on them straight away. Don't try and left click on them because you'll never be able to select them. The computer's a bit funny like that. Okay. That one can go, that one can go, that one can go. Looking good. Okay, so we're making progress, not much wasted space. I'll click on artwork for a second. This is what the finished result will look like at the moment that we're going to print off. There's my strain relief, there's my battery, there's my diode there, looking good. Okay, what should we stick in next? I'm still in the circuit diagram. So we've done this, done this, done this, done that, done the download socket that you don't normally see. Let's actually think about this now on a pin-by-pin basis. That seems a smart thing to do. Pin 1 is done, that's connected up. Pin number 2 is done, that's connected up. Let's do pin number 3 next. Pin number 3 is for output 4. You see there? It says that on the little tooltip thing, output 4. So let's do output 4. What's output 4? Output 4 is a resistor and 2 LEDs. Okay, resistor and 2 LEDs. Do I want to do that one next? Actually, I'm quite tempted to do the switch. And the reason I'm saying to do the switch is just purely because the switch, when you look at it, is physically larger. There we go, that's the switch there. Look, it's physically larger than the other components. So actually, I'm going to do the switch. The order doesn't really matter. It's just people get stuck in their ways like me. And I know that the switch has got a 10k pull-down resistor that goes with it. So let's go and grab that. Once I finish this tutorial, what you might want to do actually is have a go at designing your own version of this, because if you attempt it in a different order when you place the parts, you end up with a very, very different result. You know, one of the great things about doing this is there's no one absolutely right way to go about doing this. You know, there's a whole bunch of different ways to get a finished solution. Okay, the switch. Now the switch needs, let's have a look at these green lines. The switch needs power, yes it does. And what else does the switch want? I wonder if I can get that switch in there. There's a little gap in here. I'm quite tempted to have a go for that, you know. I'm going to try and put the switch here. In order to do that, I wonder if I can get that to sneak up there and get that to sneak back there. These two are quite close now. Got to watch that. I think we'll get away with that though, that's okay. Okay, so I'll put my switch just here. Once I've got my switch there, I need to think about how to wire it up. And the first thing the switch needs is a connection to 5 volts, and the bottom of the switch goes into pin number 4. Let's do that. So the top of the switch connects to 5 volts. Well, I've got 5 volts just here. Okay, so I'm going to take that from there, and top of the switch into 5 volts. In fact, I just connect it like that. Look, straight in. Okay, bottom of the switch goes into pin number 4, which is just here. So click on the track tool, come up, plop you in there like that. That's good. The bottom of the switch also needs to go through a 10k resistor to 0 volts. Let's do that. So here's my 10k resistor. Here's 0 volts. Those two are quite close together. How can we do this? I suppose I could turn this 90 degrees. That could work. Slip that just there. And you can go like that into there. That looks good. And you can go into there like that. That looks pretty good as well, actually. I'm quite pleased with that. delete some labels. Looking good. Right click on this green line, get rid of that. That one's done, that one's done, that one's done, and that one's done. Right, what should we do next? Let's look at this input. That was a pair of LEDs, wasn't it, I think, as I recall? Yes, it was. It was this. Okay, let's do that. So I'm going to go and grab some LEDs. It doesn't really matter which LEDs. I'm sure the lines here have got very, very specific ideas about which LEDs they'd like you to use. But again, this is just, you can delete this. It annoys me completely. I really don't find this useful. Delete, delete, delete. Just grab two LEDs. And there's a resistor as well. Again, look, not interested in what you think. I'm in charge here. That's it. Okay, two LEDs, resistor. Cool. So, in order to connect this up, we need to go from the output to resistor to the LEDs to 0 volts. In actual fact, it's electricity, so we could do the LEDs first if we really wanted to, but the resistor is quite a convenient thing to start with, so I'm probably going to see if I can do that. So let's have a look at how we can do this. Okay, resistor. I'm going to take this resistor, I think, and I'm going to put it just here. Seems pretty good. Let's try that and see how that plays out. I'm going to get my track tool and I'm going to come out and go inside the board like I've done before, to the left, and connect you up just here. So that's that part done. Let's delete some more of these green lines because they continue to taunt me. There we go. Okay, other end, the resistor now. Delete some labels again so you can see what we're doing. And we need a pair of LEDs connected together in parallel. I'm actually going to spin the LED. Notice you've got that flat edge on there, and with an LED, one leg's longer. But another way you can tell is the flat edge of the LED is the negative end. So I'm going to stick that LED there. Okay, keep my nice compact design still. Get that one, spin you 90 degrees, and stick you just there like that. Track tool comes on, and we're going from the resistor into the positive end of the LEDs like that. And then from the negative end of the LEDs, we go to 0 volts, which is just here. So it's quite easy. So, and like that. Okay, beautiful. Okay, again, still really nice, small, dense, well packed together board. What should we do next? Let's do some more LEDs, because that's all we've got left now, really. My last few LEDs, I can kind of recognise at this point my PCB doesn't need to be quite this big as well, so maybe it's time that we shrunk that down a bit. Grab our last few components and stick those on here. Okay, then we've got to keep zooming in and zooming out all the time. Okay, let's look at these remaining few things. On my Genie chip, by the way, I've got I need a connection to ground just here to 0 volts. And what a lot of people will do, little inexperienced thing, is they'll go like this. So right, 0 volts is here, here, and here, and here. So let's go a bit like that, and that, and that. And if you go and do that, that's fine. You can do that if you want. But if you do that, all of a sudden you've got a problem, because how are you going to get to here for 2 LEDs, and here for 2 LEDs, and here for 1 LED, whichever the order might be? How are you going to do that? You're not, because you've got no space left. So actually, what's a bit smarter thing to do instead is to borrow 0 volts from up here. Okay, not something you'd always think to do at first. Okay, but yeah, I'd borrow 0 volts from up here. And what I would do is I'd work out that it comes to about here. Okay. And I would use the empty space inside the download socket like this. Da, 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 da. Okay. And I'd sneak it in like that. What this now means, you see, is you've got easy access again to 0 volts, and also you've got easy access to the side of your Genie chip to finish building your circuit. So that's the smart money if I was you. Okay, let's place the next couple of components then. Now we need to know which one's output 0, because output 0 is the one that's only got 1 LED. It turns out it's this one here, pin number 7. So let's get pin number 7, and for you, we shall have, what do we think, this way around? Quite a few LEDs though still. I'm wondering at the moment basically whether to stick it in this way around and to have a string of the remaining resistors kind of like this, which actually I think I'm going to do like that. Okay, or I was debating trying to get them all vertical and then putting my LEDs in. I actually think, given the number I've got, again, I've not actually wired these up yet, okay, but I kind of think that I can probably get something like that, and that, and that, which will let me shrink this board down to about that sort of size. So yeah, I'm going to leave my resistors horizontal. Again, if you try and do your own one of these, then see if you can experiment with the vertical layer, see if you can make a smaller PCB than me. Always very, very happy to see that done. Let's do it. Okay, let's pull these out of the way for a second. Right, so what I'm going to do as well is I'm just going to give this a tiny little bit of space, just so when I'm soldering it together, I'm not too close to my Genie chip, just make it easier to physically build. I'm going to connect there to there, there to there, and there to there. Just overshot slightly with that one. Let me just hover the mouse over this, make sure I'm right. Output 0, good. Output 1, good. And output 2, good. Because I've already got output 4 over here somewhere, haven't I? That's it, good. So I'm doing it correctly. It's the same as my circuit diagram. Right, let's just make sure. Output 0 was the one that only had one LED on it. So let's do that one first, I suppose. Whereabouts do I stick you? Probably up here somewhere. I might spin it this way for that one. Let's give it some labels again. Spend my life deleting labels. Okay, and let's do that, and let's tuck that in quite sort of tight as well, a bit like that. And we know that once the current's passed through the resistor, it then needs to go up and into the LED, and after the LED, it needs to go to 0 volts, which rather conveniently is just there. So that's the single LED done. Let's delete some of those green lines as well, so we don't clutter our viewpoint too much. Okay, the other two now are just a pair of LEDs and a pair of LEDs that need to get to 0 volts. Let's see what we can do to find those at home. I'm going to do this bottom one next. So I'm going to spin you around this way this time. Place you here, make sure it's not touching any of these other things, so it's not too close. Take this one, spin that around 90 degrees, tuck that into here. Now let's run some wires, so, some tracks, sorry, so that can go into that one. Also into that one, and then from here it needs to get down to 0 volts, which is quite convenient to do that from there, so that's good. And then the last two LEDs and we're finished. So far pretty plain sailing actually. Let's delete these. I need to get from here to these two and then over to 0 volts. Let's have a look. Might spin you around as well actually. Let's have you there, and let's have you do you know what? I'm gonna go like this. I'm gonna have it that way around, like that, and like that. Sort of touching, but we're not actually mounting the PCBs flat onto the circuit board itself. These are going to be running off of wires, so they can be like that. They can be just touching. That's fine. Let's do it. So we come from here. We come out a little bit, up a little bit. Tuck it back in a little bit, up a bit there, into the LED, and into that one, the positive, and then for the negative, it goes from there to there, into there like that. And actually, if I'm not mistaken, I think that is all the wiring. That's it. We've done all the components. We're done. Okay, last thing that remains then, let's tuck in this edge now. Okay, bring that in. Let's tuck in this edge. Let's slide that back into its corner. Let's put my other drill holes so I can physically attach everything once this is all finished. Okay, and I could actually produce this. We'll click on artwork just so you can see it. I can produce this right now, solder it together, and I'm pretty sure that would work. Let's look at the size. This one is about 40mm by about 40mm. If you remember, our original one, our automatic one, was 8cm by 8cm, so twice the size. We've literally half the size of the board by designing it for ourselves, which means we could have a half as bigger actual end product, the die itself. So this is all about miniaturization. Another thing that you do need to do as well before you can finish is you need to put some labels in, because if someone handed you this and said, can you solder that together, you wouldn't have a clue what you were looking at. So we're going to put some labels in to make it a bit easier to work with. You're not going to go crazy with labels. It's just like you're giving yourself clues to make it easier to build. So one of the things I might do to start with is I might be tempted to put a label near here somewhere for my power, although there's no real space, I probably can't do that. Resistors is a good one though. This one here's a 10k resistor. So what I'm going to do is grab my label tool. That was that capital A and lowercase a. Click in here, type in 10k. Now that label's enormous, so I'm going to right click on it, go to font, and you can change the font size down to about size 6. That's about the smallest you can use. So I'd use that. I'm actually going to put that 10k in between the two resistor holes. I'm also going to turn off my grid snapping. It means that rather than objects moving around in very, very sort of strict blocks of distance, now I can move things as much as I want. There you go, so that's that 10k neatly in the middle there. I've got some more resistors here. These are all 220s, I think. So I'm going to take this one, I'm going to copy it, and I'm going to paste it. Control V to paste. I'm going to paste that in here. So I'm going to label these resistors. 220s, copy paste again, stick that in there. Don't think I've got enough space to put 220 in there, so I'm going to have to leave that one. For my LEDs, because some LEDs are all different ways up, I'm going to put a little plus next to some of my LEDs so I know which way around is positive. Again, tuck that right in there. That'll get a little plus as well. Okay. So that even if I have to look at my circuit diagram and I know that that's an LED, at least I can tell, visually which end's positive. I might have some more pluses in here. Okay, you can probably do that for the rest of your LEDs. What else we got? This one's a switch, so I might put a little swir in there if I can do that. Let's have a look if we can get that in neatly. You see, what you don't want to do though is you don't want to put it in like this, otherwise the bottom of that S and the top of the S is so close that when you solder, you end up actually soldering these two things together and you create a problem. So if you do want to put in little helper labels, do make sure you don't end up causing yourself any problems. So I've sort of moved that off to the side. It's not a problem if this pad touches this S, but it is a problem if anywhere on this S touches another track, or if this S sort of touch that W, and if that W touched that track, that's a problem. That's what you're going to avoid when you're doing circuit design. No point putting a label on for the download socket, because if we look at the artwork, the download socket's very, very distinctive. It's got these sort of square pads up at the top that no other component's got. Another good thing to do is to actually put your name on your work so that I know it's yours. So I'm going to put on mine, Mr. Brown. Okay, I'm going to rotate that and stick that in here. I should probably also say what the actual project is as well. So if I ever have to try and dig out that circuit again, at least I'll know straight away when I pick it up and look at it what it is that I'm holding in my hands. For the voltage regulator, I always try and label either the input or the output. I just did those in the wrong order. That's the input. So I'm actually going to put a label in there, and I'm going to label that in. So now it's input, rotate it 90 degrees, stick it back where it belongs. That's helpful. Diode, people love to put diodes in backwards. So for a diode, I'm going to do 2 minus signs and a greater than sign. It looks a little bit nothing like an arrow. Okay, put that in position so I know that that's a diode and it has to go that way. That's a good one you can do. What else have I got I could do? Genie chip's a good one as well. With Genie chip, people love to put those in upside down. So find pin number 1, or any pin that you can get a label on clearly, and stick a number on it. So that's pin 5 down there, for example. So I might be tempted to stick a pin number 5 there, or stick a 1 just here. You don't need to do both. As long as you label one pin, and you can usually work out what everything else is. Just be careful again that your 1 doesn't get too close to anything else. Any more I can think of? Yeah, do the other LEDs, and then you're kind of done, really. Actually, well, I suppose we better test that this works, haven't we? We've come this far, so let's just do that. To test it works, what you want to do is go back to Real World View. There she is. And go into your component shopping list, and at the very, very bottom of that list there's a red section that says off-board components. So you're going to need to choose power supplies. Grab yourself a 9-volt battery. You notice, I'm just going to stick that there. You notice how huge that is compared to your circuit? Okay, that's just how small the thing that you've just designed actually is. Isn't that incredible? Okay, look, you can almost cover the board with a 9-volt battery. And what I'm going to do is connect the positive end of the battery to the the positive power rail, and that one goes on there. Also need a switch as well, because our switch is going to get sort of screwed in here. So switches are down there, push to make switch I think. Flip that around 90 degrees, so I'll pop that in place. And again, one end of the switch, doesn't matter which, goes in there, other end of the switch goes in there. Right, moment of truth, let's see if we did a good job. Click on play. Okay, so the program first runs, it shows us a 6, that's exactly what it should do. Click and hold down the button. and it blinks lots of lights, and it shows us the number that we've rolled. There you go, just rolled a 1, just rolled a 5, whatever. So that looks to me like it's working pretty good. You can also go to current flow as well. Look, you can see the electricity flowing through your circuit that you designed as well. All very, very grand indeed. Okay, so there you go. That is how you design the PCB for the digital die. Join us again in the next episode, where we'll look at more sophisticated ways to program your circuit. I'll see you then.